Welcome at Vandewiele. We are a leading machine builder for the international textile industry, and this means that we provide our customers with machines that extrude textile yarns, but also machines that create carpet, velvet and even artificial grass. In order to develop these machines, we have R&D teams across the world, but we are headquartered here in Marken, close to Kortrijk, where we also have an on-site foundry and a state-of-the-art production facility. If you're wondering how impressive our machines are, we can create carpets with a width from 2 meters up to 5 meters. Even more impressive is the number of yarns we need to create these carpets. Whether it's tufted or woven carpets, we can go up to more than 20,000 yarns for a single carpet, which are controlled individually. Our tufting machine is a very high speed machine, and those machines do not rotate, they oscillate. They see very high accelerations, and you know that acceleration times mass equals the force. So self-weight of our components is extremely important for us, and there is where we want to challenge you. So this is our newest generation of high-speed tufting machine, and this machine also nicely demonstrates our keen focus on lightweight components. For example, we have a carbon fiber needle bar for moving the needles up and down. We have a lightweight aluminium design of a pushrod foot, and this part is where we want to focus on. This is the pushrod itself, which drives all of these components. To give you an idea, all of these components move at 2,500 RPM, but the peak acceleration each component sees is close to 100 G, at the rate of more than 80 times per second in the upper position and in the lower position. If you want to go even faster with an acceptable load, we need to lower the self-weight of each individual component. This is the part which is assembled over here and what the actual challenge is about. What is important to notice is that these are at the moment an assembly of 2 steel components, and that this face is hardened. This is because we have an oil ring running over it. We want, of course, to keep the oil in the machine, and this makes contact with the linear guidance. This part is also hardened because there is a pin oscillating in it. As you can see, this is already drilled out, but it still weighs quite a lot because of the thickness of the walls of this tube. An ideal additive manufacturing solution could be that, for example, the interior of this rod has a 3D structure to safeguard its strength and stiffness, but also to attain a minimum self-weight of the part, of course with an outer surface that is still hardenable. In order to support you with this challenge, our R&D team is at your disposal. We already have some in-house experience with 3D metal printing. We also have a measurement lab which is fully equipped for hardness, tolerances and even tensile testing. And if you want to do some early prototyping, we also have an FDM printer available for concept validation in plastic. For us, a lightweight pushrod will enable us to go even faster and increase the energy efficiency of our system even more than today. The students will be invited over to collaborate with our R&D department, and they will contribute to a more efficient and performant textile industry. If you are as passionate as we are about high-speed machines and want to collaborate with an R&D department of a world-class machine builder, then take Vandewiele as your AM challenge, and I will be happy to welcome you here in Kortrijk.